Okay, let's kick this off with some numbers.
Yeah.
Because the ones that start this deep dive, they're pretty startling.
Yeah, really eye-opening stuff.
We're looking at over 30 million vehicles recalled globally in just 2022.
30 million.
In 1 year.
And it's not just, fussy infotainment systems. We're talking everything from software glitches right through to mechanical flaws that could be, fatal.
That number, 30 million, it really sets up the core puzzle we're tackling today, doesn't it?
It absolutely does. And that's our mission for this deep dive, using the great sources you shared with us. We want to unpack this paradox.
Mm-hmm.
Why do we still see these fundamental quality problems, especially in cars, when the technology is just so advanced?
It's a strange situation.
How can these rolling supercomputers still get tripped up by something as basic, seemingly as a loose bolt?
It is a fascinating paradox, yeah. You've got cars with, the sources say more lines of code than a jet airliner.
Which is just wild to think about.
Right. Bristling with sensors, advanced AI, doing all sorts of incredible things for navigation, safety.
And yet, still grappling with fundamental mechanics, assembly issues.
Exactly. It feels like this huge disconnect between the cutting edge digital side and the nuts and bolts, literally.
And the material makes it clear this isn't simple.
Mm-hmm.
We're going to dig into the causes, the consequences, and they are huge for safety, the economy, the environment.
And then look at what the industry is trying to do about it, or maybe should be doing.
Yeah, it touches on so many things. Technology, obviously, but also global supply chains, people, company culture. It's a big tangle.
Ready to unpack it.
Let's do it. So the heart of it is that contrast you mentioned. Super sophisticated vehicles.
Incredibly sophisticated. The research mentioned, a premium car today might have over 100 million lines of code running things.
Wow. That's just hard to wrap your head around.
Yeah.
More than a jet. You think about self-driving features, complex infotainment, constant connectivity.
Space age stuff, like you said. And you'd think, okay, if they can manage that level of complexity, surely the basics are flawless.
But they're not. The materials highlight these recalls for things that feel almost, primitive, like bolts, fasteners.
Yeah, that example really stood out. Bolts and fastening system.
Bolts. The things literally holding the car together. How is that still a recurring problem?
Well, it turns out it's not just having the bolt there. The crucial thing is the torque. Getting the tightness exactly right.
Okay.
The sources explain, if it's too loose, it can vibrate, work itself free, things fail. Too tight, you actually weaken the bolt. It can just snap later under stress.
And the consequences when these bolts do fail.
Yeah.
The material laid out some pretty scary scenarios.
Yeah, definitely.
Suspension failures.
Yeah.
Potentially losing control of the car completely.
Or fuel system leaks from loose fittings. Big fire risk there.
And then there's the EV angle, which adds another layer.
Right, exactly. The material flagged major concerns about the bolts holding down those massive, heavy, high-voltage batteries in EVs and hybrids.
If those fail.
Well, the battery can shift. You could damage the cells, short circuits. A very serious fire hazard, much higher risk perhaps than with traditional fuel leaks.
Okay, so here's the bit that makes you really scratch your head. The paradox within the paradox, almost.
Mm-hmm.
The tech to get torque, right? Calibrated tools, automated systems. This isn't new, right? It's been around for decades.
That's exactly right. The technology itself is mature.
So why do these problems still happen if we know how to tighten a bolt properly?
That's the million-dollar question, isn't it? It suggests the problem isn't the lack of technology, but maybe implementing it effectively, consistently within these incredibly complex, fast-paced assembly lines.
So other factors are messing it up.
Could be. Things like, the sheer speed of production, limits in how well automation handles tiny variations, maybe even environmental factors over the car's life affecting those connections. It points to something deeper, more systemic.
Right. Which leads us nicely into the root causes. Because it's obviously not just one thing going wrong.
Oh, absolutely not. The research paints a picture of several big factors, all kind of converging.
Okay. Like what?
Well, one major one is this huge shift in focus and resources inside the car companies.
Towards the tech, the software, autonomous driving, connectivity.
Precisely. That's where enormous amounts of engineering brainpower, investment dollars, and senior management attention are going. It's the sexy stuff, the competitive edge.
And the potential downside is maybe perfecting the door latch or the exhaust bracket doesn't get the same intense focus it used to.
That seems to be a real concern. I remember that quote in the material from the anonymous chief engineer.
Oh, yeah, that stuck with me too. The true innovation today is ensuring even the simplest elements work impeccably within increasingly sophisticated systems.
It's a really insightful point because that integration is the hard part.
So focus shift is one thing. What else?
Just the sheer mind-bending complexity of the modern vehicle itself.
Right. You mentioned 30,000 parts earlier.
Up to 30,000 parts. And they're all interconnected. Mechanical, electrical, software. This incredibly dense web of dependencies, trying to map out and predict every single potential failure mode in that system. It's incredibly difficult.
Almost impossible, you'd think.
It presents huge hurdles. And this complexity, it's made worse by what the material calls silos.
Meaning different engineering teams not talking to each other enough.
Yeah, essentially, you've got your mechanical engineers, your electrical engineers, your software gurus.
Yeah.
Becoming more and more specialized.
Which is good for depth, maybe, but bad for the interfaces between them.
Exactly. Communication breaks down. Understanding across disciplines can weaken. You get these unexpected interface problems. And there's also that concern raised
about newer engineers maybe not having that deep gut level feel for basic mechanics.
Right. Compared to older generations who maybe spent more time, getting their hands dirty with the physical stuff before everything became so heavily software driven, it's a potential skill gap.
Okay, so internal factors.
Mm-hmm.
But then there's the whole world outside the factory gates. So supply chain. That sounds like a minefield.
Oh, it's a huge factor. Absolutely. Cars today are patchworks, assembled from components made by hundreds, sometimes thousands of different suppliers.
All over the globe?
All over the globe. China, Mexico, Germany, Southeast Asia, you name it. And trying to maintain consistent, direct quality control over that vast fragmented network, it's incredibly challenging.
And the relationships are complicated, right? Contracts.
Very complex, often driven heavily by cost pressure, which unfortunately can create incentives, intended or not, for suppliers maybe to, let's say, not be as rigorous with quality checks as they perhaps should be.
Plus different standards in different places, language barriers.
All of that plays a role. Communication hurdles, varying regional standards.
Yep.
It's fertile ground for defects to slip through.
And you mentioned cost pressure driving supplier relationships. That must be a factor across the board.
Oh, absolutely. It's a fiercely competitive market. Everyone needs to keep prices down. And that pressure inevitably leads to compromises somewhere.
Like?
Well, the material mentioned things like decontenting, maybe quietly removing a small feature or simplifying a component to save money.
Or using slightly cheaper materials.
Or even just reducing the number of fasteners holding something together. Saving a few pennies per car, maybe, but potentially impacting long-term robustness.
And all of this is happening at lightning speed. That production line pace. Building a whole car in, 60 to 90 seconds?
Yeah, that figure is wild. It creates enormous pressure.
Not much time for careful double checking.
Very little margin for error. Think about the stress on human workers on the line. Fatigue becomes a real factor. And even the automated systems, they're being pushed to their absolute limits.
Plus that just-in-time philosophy.
Right. While it's great for minimizing inventory costs, it means parts arrive literally just before they're needed on the line.
Leaving less time to inspect them thoroughly when they come in the door.
Exactly. Less buffer, less time for incoming quality control. It all adds up.
So, okay, we've got this perfect storm, really. Insane complexity, focus shifting to software, fragmented global suppliers, constant cost pressure, breakneck production speed.
It's a potent mix.
So when things do go wrong with these basics in these super advanced cars, what's the fallout? What are the consequences we're seeing?
Well, they're massive, starting with what we began with those huge recalls, tens of millions of vehicles every year.
And like we said, not just annoyances, real safety risks, potential fires, especially with EVs.
The battery anchor issue.
Or losing control because a suspension part failed. These are serious, life-threatening possibilities.
An economic hit. It's just staggering.
Yeah, talk about that. It's not just fixing the cars, is it?
Not even close. You've got the direct costs, sure, notifying owners, the logistics of the recall, the parts, the dealer labor. But then there are the indirect costs.
Right.
Damage to the brand's reputation, that's huge. Lost future sales because people lose trust. Enormous legal fees from lawsuits if people get hurt. And then hefty fines from regulators.
The sources gave some pretty stark examples there. Takata airbags, the total cost across all the affected companies.
Estimated over $24 billion.
Billion, wow.
Yeah.
And the GM ignition switch, disaster.
Tragically linked to, I think, 124 deaths. The fines, the lawsuits. It can genuinely threaten a company's survival.
And there's an environmental cost too, isn't there?
Mm.
Which maybe we don't think about as much.
That's a really good point. Recalls mean waste. Millions of replaced parts have to go somewhere, often landfill.
Plus, making all the new replacement parts uses energy, resources.
Right. More emissions, more resource depletion. And then you have defects that directly harm the environment, like things affecting emissions controls. Remember Dieselgate?
Oh yeah, the defeat devices.
Or even just issues that hurt fuel efficiency. It all adds up.
And legally, the car makers are definitely on the hook.
Oh, absolutely. They have clear legal duties. They have to meet safety standards set by law. They have to report potential safety defects to the authorities, like the National Highway Traffic Safety Administration, NHTSA here in the U.S.
Then they have to fix them, right? Issue recalls.
Yes. Implement corrective actions. If they fail on any of that, they face serious consequences.
Excellent.
Product liability lawsuits, big regulatory penalties. NHTSA can fine them, thousands per faulty vehicle, potentially adding up to over $100 million for a related series of violations.
And hitting them perhaps where it hurts most in the long run. Consumer trust.
That erodes so quickly. The data in the material was pretty clear on that.
What did it say?
Something like 65% of buyers put a reliability at the top of their list, and nearly 80% said they'd be much less likely to even consider buying from a brand that just had a major safety recall.
And bad news travels fast these days.
Instantly. Social media just amplifies everything. One bad story, one big recall can spread globally in hours. And, people just expect more now. Good enough really isn't good enough anymore when you're spending so much on a vehicle.
Okay, so it's a complex mess with serious consequences. Given all that, how does the industry start to fix this? What are the paths forward suggested in the materials?
Well, the sources point to several key areas needing serious attention. And maybe the most fundamental one is about culture.
A cultural shift within the companies.
Exactly. Quality can't just be a department down the hall. It needs to be like a core strategic value embedded everywhere, starting right at the very top leadership.
Makes sense. It has to be driven from the top.
Yeah.
The material mentioned creating a culture where people feel safe speaking up about problems.
Yeah, that's crucial. Like Toyota's famous Andon system, where any worker can literally stop the entire production line if they spot a quality issue without fear of being punished.
And that idea of a just culture.
Right. Balancing accountability with learning. When something goes wrong, the focus is less on blaming individuals and more on understanding the systemic failures that allowed it to happen so you can fix the system.
Okay, so culture is foundational. What else?
Really integrating quality across the board, breaking down those silos we talked about.
So mechanical, electrical, software engineers all working together on quality from the start.
Yes, thinking about it holistically. The sources mention this concept of a digital thread.
What's that?
It's basically using technology to create a seamless flow of data about the product's quality. All the way from the initial design concept through engineering, sourcing, manufacturing, testing, and even tracking performance once the car is out on the road.
So you get this complete end-to-end picture. Helps you spot where issues creep in.
Precisely. It gives you the visibility that these fragmented systems often lack, and that visibility needs to extend out to the supply chain too.
Right, got to fix those relationships.
Yeah, moving away from purely transactional cost-focused deals with suppliers towards more strategic long-term partnerships, building trust, sharing quality goals.
Does that mean making more critical parts in-house again?
Maybe sometimes, or what the material called right sourcing, choosing key suppliers for critical components very carefully, maybe investing in their capabilities, working much more closely with them, building true partnerships.
What about testing? Finding flaws before the cars ever leave the factory.
Huge area. Advanced testing and validation are critical, and the methods are getting more sophisticated. It's not just physical crash tests anymore.
More computer simulation.
A lot more. Simulation, virtual testing, creating digital twins, these incredibly detailed virtual models of components, systems, or even the whole car to predict how they'll behave under all sorts of conditions before you even build a physical prototype.
And then still doing rigorous physical tests.
Oh, yes. Component tests, subsystem tests, full vehicle tests, running pilot production batches and paring them down to scrutinize everything before you hit mass production. It has to be multi-layered.
And can technology help prevent mistakes on the actual assembly line?
Definitely. That's where poka-yoke comes in. It's a Japanese term, basically means error-proofing.
How's that work?
Designing things so mistakes are either impossible or immediately obvious, like a connector that physically only fits one way.
Or tools that won't let you proceed if you haven't tightened a bolt correctly.
Exactly. Smart tools that confirm the right torque, vision systems that check if a part is installed. building quality checks right into the process itself, making it hard to get it wrong.
That sounds really smart. Make the mistake impossible.
It's about designing quality in, not just inspecting it at the end. And the material also suggested looking outside the auto industry for ideas.
Learning from other fields. Like who?
High reliability sectors, think aerospace, nuclear power.
Okay, yeah, they can't afford mistakes.
Yeah, right. So they have incredibly strict processes. Rigorous certification for every part, lots of redundancy built in, meticulous traceability, knowing exactly where every critical component came from, sometimes right back to the batch of raw metal. And that just culture we mentioned is very strong there too.
Any other examples?
Maybe using detailed checklists like they do in surgery to prevent errors, or sophisticated predictive maintenance planning like high-speed rail networks use, borrowing best practices.
What about the regulators? What's their role in pushing for better quality?
They're essential. Agencies like NHTSA set the minimum safety standards cars have to meet. They investigate potential defects reported by consumers or the companies themselves. And crucially, they have the power to order mandatory recalls if they find an unreasonable safety risk.
Are standards getting tougher or changing?
There's definitely a push towards harmonizing standards globally, so manufacturers don't have slightly different rules everywhere. That UN group, WPP 299, is working on that. And a move towards standards that focus more on the required safety outcome performance standards rather than dictating the exact technical solution.
Giving companies flexibility but holding them to the result.
Exactly. And transparency is becoming more important too. Companies being open about issues, maybe even proactively disclosing potential problems.
And what about us, the people driving these cars? Do we have a role to play?
We absolutely do. The material really stressed the importance of just basic preventative maintenance. Following the schedule in your owner's manual, that can catch potential issues early.
Yeah, but people often skip that.
They do. And that leads to the other challenge. Recall completion rates are often surprisingly low. Millions of recalled cars never actually get fixed.
Why is that?
Sometimes communication isn't great. People move, notices get lost. Maybe the recall doesn't seem urgent. Car makers need to do better, clearer, more direct notifications, maybe using the car's own connected systems to deliver alerts and help schedule the repair.
But at the end of the day, it's still on the owner to respond.
Ultimately, yes. As owners, you have a responsibility to pay attention to potential warning signs your car might be giving you and to get recalls and necessary maintenance done. It's part of safe ownership.
Okay, one last point. The sources brought up this link between quality and sustainability.
Yeah.
And social responsibility. How does that fit in?
Yeah, that's a really interesting convergence happening. The idea of what makes a quality product is actually broadening.
Beyond just, does it work right now?
Exactly. It's increasingly including things like durability. How long will it last? Is it easily repairable? Was it built using ethical labor practices and sustainable materials throughout its supply chain?
So environmental impact and social responsibility are becoming part of the quality equation.
More and more, yes. Consumers, especially younger ones, care about these things, and companies are realizing that building high-quality, long-lasting, repairable products with a clean supply chain, well, that aligns with both good business and good corporate citizenship. It's becoming integral to the brand image.
Okay, so let's try to wrap this deep dive up. The bottom line seems to be, the big challenge for the car industry now isn't just inventing the next amazing piece of tech.
No, not at all.
It's the incredibly difficult job of weaving all that cutting-edge software and electronics seamlessly together with basic, reliable, fundamental mechanical and electrical systems.
Making sure everything works perfectly from the smartest AI algorithm right down to, well, the humble bolt.
It really demands that systemic shift you talked about. Culture, integrated processes, collaboration across those old silos, smarter supply chains.
And using technology wisely, using it to support and guarantee that fundamental quality, not just adding more layers of complexity that might hide or even create new problems.
That paradox we started with, the super smart car, recalled for a basic mechanical part. It just perfectly illustrates that integration challenge, doesn't it?
It really does.
It definitely leaves you thinking. Cars are only getting more complex. Supply chains aren't getting any simpler. Tech is moving faster than ever. So what does the future of quality and safety actually look like?
Will the industry manage to nail this incredibly complex integration? Or are we going to keep seeing these foundational flaws undermining trust in ever more sophisticated vehicles?
And maybe for you listening, when you think about your next car, how will you judge its quality? What matters most beyond the flashy screens and features? What really tells you it's built right? from the ground up?
That's the critical question, isn't it?
It is. A huge thank you for bringing us the sources that let us dive into this. It was fascinating and, yeah, a bit unsettling too. Definitely a lot to chew on.